Interface Segregation Principle. Welcome to the series of videos on the solid design principles, where we will explore each principle in detail. In this episode, we will focus on the Interface Segregation Principle, ISP, and how it can help design cohesive and maintainable interfaces for complex software systems. We'll use the example of the McNoodles ordering system to see how breaking a monolithic interface into smaller, more specific ones can lead to improved code quality and maintainability. Imagine an intergalactic restaurant chain called McNoodles that has a complex ordering system. The system consists of a cloud application that manages orders, a mobile app for customers to place orders, and a web interface for restaurant managers to create menus. Each part of the system is developed by a different team located in different time zones, which means that they have limited time to communicate with each other. As a result, the system's design must be cohesive and specific, with each component depending only on what it needs from the others. However, the current design of the McNoodles system violates the interface segregation principle. The core application interface, which all clients depend on, contains methods that are not needed by all clients. For example, the mobile app only needs to place orders and browse the menu, while the web interface only needs to create menus and add special offers. This monolithic interface forces all clients to depend on methods they don't need, which can lead to maintenance issues and dependencies between components. However, both clients are forced to depend on methods like inspect database and leave review, which are not relevant to their needs. This violates the interface segregation principle, which states that clients should not be forced to depend on methods they don't need. Applying the interface segregation principle to the McNoodles core application can lead to a more modular and maintainable system. We can start by breaking down the monolithic McNoodles interface into smaller, more specific interfaces that contain only the methods that each client requires. For example, we can create a menu creator interface that contains only the create menu and add special offer methods. This interface can be implemented by the Web UI class, which provides functionality for creating menus and adding special offers. Similarly, we can create a reviewer interface that contains only the leave review method. This interface can be implemented by a separate class that handles reviews and ratings for the restaurant. Finally, we can create a menu browser interface that contains only the browse menu method. This interface can be implemented by the mobile client class, which provides functionality for browsing the menu and placing orders. By breaking down the interface into smaller, more specific ones, we can ensure that each client only depends on the methods they require. This allows for easier maintenance and version control, as changes made to one interface will not affect the other clients. Additionally, the use of smaller, more specific interfaces makes it easier to develop and test individual components of the system. Benefits of ISP. Increased modularity. Breaking interfaces into smaller, more specific ones makes it easier to modify and extend the system without affecting unrelated clients. This is because each client only depends on the methods they need, so changes to one interface won't affect other clients. Reduced coupling. Clients only depend on the methods they need, which reduces coupling between the system's components. This makes it easier to change one part of the system without affecting others, because there are fewer dependencies to worry about. Improved maintainability. With smaller interfaces and reduced coupling, it's easier to isolate and fix bugs or make changes to specific parts of the system. This means that maintenance becomes less complex and time-consuming, making the system more robust and reliable. Better scalability. ISP helps avoid bloated interfaces that become unwieldy as the system grows. Instead, the system can evolve in a more manageable way by adding new, more specific interfaces as needed. This allows the system to scale more effectively and without introducing unnecessary complexity. That concludes our discussion on the interface segregation principle. By breaking up large interfaces into smaller, more specific ones, we can greatly improve the maintainability and quality of our software. It's worth noting that just like how AI tools were used to generate this content, you too can leverage technology to improve your software development process. Remember, incorporating the interface segregation principle into your software design can lead to happier customers, smoother maintenance, and faster development times. So give it a try in your next project and see the benefits for yourself. Thank you for watching, and I hope to see you in the next video in this series.